Going over to number 7 now. Here, we always start right here. Which choice describes the overall structure of the text? It's kind of a main idea thing. So let's go ahead and try to get that main idea. So, changes to vegetation cover and other human activities influence carbon and nitrogen levels, though how deep these effects extend is unclear. Hypothesizing that these differences in land use lead to differences in carbon and nitrogen levels that are not restricted to the topsoil layer. These people sampled soils across multiple land use types within each location. They found, though, which is important because it's an opposite, they found, though, that across land use types, carbon and nitrogen decreased to comparably low levels beyond depths of 30 centimeters. So let's start taking this apart. So human activities influence carbon and nitrogen levels, but how deep they extend is something that we need to find out more about. So the hypothesis was that differences in the land use lead to differences in the levels and that they're not restricted to the topsoil layer. So the original belief is that the damage that's being done to the land goes deep into the land. It's not restricted to the top layer. It actually permeates deep within. And so what they did is they sampled soils within a bunch of locations, and what they found was that carbon and nitrogen decreased to comparably low levels beyond depths of 30 centimeters. So what's being said there is that the levels would always go to pretty low levels once you get deep into the ground. In other words, if there's this concern that the damage that's being done to the land goes deep into the land, we're actually finding out that no, it's just on the surface. When you get to the low levels beyond a depth of 30 centimeters, they're just low levels. The same damage, the same pollution of carbon and nitrogen is not happening anymore. So let's start looking at the answers. A says it describes a phenomenon that scientists do not fully understand. That's pretty good. Explains a team's hypothesis and then describes a finding that led the team to refine the hypothesis. Not bad. If there's nothing better, we'll keep it. B introduces an unresolved scientific question. That's pretty good. Presents a research team's hypothesis pertaining to that question, and then describes an observation made by the team that conflicts with the hypothesis. That's definitely better because the results did conflict. They found, though, which is that opposite word there, that it actually doesn't have a deep effect on that the dynamic they're talking about doesn't have a deep effect on the land, only on the surface of the land. Now, one more thing we don't like about A is that this is not a phenomenon. A phenomenon would be the northern lights or tornadoes or something really interesting, something almost magical that happens would be described as a phenomenon. So we weren't talking about a phenomenon, we were talking about more of a dynamic, or the way B said, an unresolved scientific question. So because of the word phenomenon, that's another reason to get rid of A. Looking at C now, it discusses a process that scientists are unclear about. We're not talking about a process, we're talking about sort of the pollution-related effects of human activity. So it's not something we would describe as a process. And then D explains a hypothesis that has been the subject of scientific debate. Well, right there, we can kind of get rid of it because we weren't seeing a lot of debate regarding this. We saw uncertainty because it says how deep those effects extend is unclear. So debate would be more if there were some people saying strongly this is having an effect, and there's other people saying strongly it's not having an effect. That would be more of a debate, which we're not seeing here. So we can get rid of D. And the answer that lasted is